Hello, specialist people. So every year I do a series called Guessing the Specialist Exam. Did it in 2022 and I did it in 2023. If you want to take a look at them, you can find them at the following place. Just go to Maths Videos Australia, go Specialist Maths, and then you can choose 2022 or 2023. If we take a look at 2022, you can see a whole bunch of videos here where I go through every question and a paper down there that you can practice. So I did it 2022 and I did it in 2023 as well. So these are really good things that you can use to help you study over the next couple of weeks. Now, that's not the only thing I've done to help you study. The other thing I've done is Project 152. So same website, if we go to Specialist Maths and we go to Project 152, what I've done here is you've got a whole bunch of like question sets. If we just open one at random, phase 13, these are questions that the QCAA have done in past exams. So you can practice these ones and they all come with a video solution as well. If I just go back here to the phase 13 video solution, click there, opens up a video and you can watch the full solution. Now, if you did every one of these over the next couple of weeks, it means you would be exposed to every single question the QCAA has ever done, which I think is super neat. Now, what it also means is that because I've been making those video solutions all year this year, I've been exposed to every single question that the QCAA has done. And I've got these like new ideas that I haven't had before about what the QCAA exam actually looks like, the sorts of questions that are in there, etc. So this video is going to be different to any other Guessing the Specialist exam because I'm not going to try to guess the specialist exam because I think you've got enough practice questions. You've got 150 questions from the QCAA. You've got the two that I've made in previous years, so an extra like 40 questions. So you've got like 200 model questions that you can practice, and you can get a bunch more. Ask your teacher for practice papers. They've got them. We're doing something different today. Now, you've kind of got to settle in though, because this is definitely going to be a long video and I want to do it all in one go. I want to make your head spin and I want you to sort of get some ideas from it. So relax, calm down, find yourself like a nice drink, maybe get a snack because we're going to be going for a little while today. Okay, what are we talking about first? Well, the thing I wanted to show you was how I'm getting these questions. Now, my absolute favorite website this year, without a doubt, has been examinsights.com. Check out Exam Insights. It's made by a couple of students from last year, but it's absolutely incredible. I've got the sciences and the maths opened up, but you can also add like a whole bunch of other subjects as well. But let me just go back a page. What I've been doing all year is going into here, going into questions, and from here, I can access every single question that the QCAA has released. And it's really, really nice. I can very, very quickly find out anything I need to know about the QCAA and what they've been doing. So for example, I can go filter. I can start looking for particular topic. Say maybe proof by induction kind of freaks me out a little bit. I can click apply. And I can very quickly see all the sorts of questions that the QCAA has ever put out for proof by induction. Now, today's video, so go and check that out because like it is an amazing website and it will save your life. Also, like my video solutions are embedded in there. So shout out to the guys at Exam Insights for putting them in there. You can watch the video when you're doing those questions. Amazing website. Check it out. But the video is not any ad for that, but you should pause the video and go and sign up because it's amazing. It's free as well. That's cool. That's not what this video is about. This video is something totally different because I've gone through every single one of these questions all year. I really feel like I've got some new ideas about how this exam looks. So without further ado, let's jump into our PowerPoint and settle in because we're doing it all. All right, so here we go. Let's get started. We'll go into our first slide here. Proof by induction. So this is what has been on the papers from 2020 all the way through to 2023 when it comes to proof by induction. So here's something that I want you to notice, right? In 2023, there was a multiple choice question, and a short response question. 6 marks in total. And in 2023, it was like a sum. And it was also a little bit scaffolded, like do part A, do part B, do part C. In 2022, another multiple choice question, and then 5 marks. Question 18 though, complex, unfamiliar, like a really difficult question. 2021, you can see here, there's a bit of a pattern going on, right? We've got multiple choice, and then we've got this proof by induction. And then in 2020, and you'll hear me talk about this throughout this video today, 2020 was like difficult exam, crazy difficult exam. I think everyone knows that. Multiple choice, and then this really, really crazy proof by induction. So that's our first topic out of the way. What I sort of want you to see here, right, is that it's pretty formulaic, or at least it has been for the past 4 years. A multiple choice question that kind of puts you in the middle of a proof by induction, and you have to figure out what the statement is, and then some actual proof by induction that's going to be worth like 4 or 5 marks, something like that. Relatively easy last year, really hard in 2022, really easy in 2021, and really difficult in 2020. So are they going to like follow some kind of pattern? I don't know. I have spoken to people at the QCAA in the past, and they say that they try to avoid patterns, but humans are humans. Humans are the people writing these things. So if in 2023 they did an easy one, and if in 2022 it was a harder one, and if in 2021 it was an easy one, I feel like we're due for a hard one in 2024. But that's what proof by induction looks like. It's 6 marks out of the 120 marks that you'll see in the external. So, you know, it's about 5% of the external exam. So keep that in mind. All right, that's proof by induction. That's everything I wanted to talk about for proof by induction. Next up, we have spheres. There's nothing there. Like, rarely have they ever asked a question about spheres. Now, again, I sort of told you, my friends at the QCAA have said they want to be unpredictable. That's sort of one of their goals. They don't want to be as predictable as the exams in the southern states. So does that mean that when I look here and I say, well, in 2023 it was a multiple choice question, in 2022 it was a multiple choice question, in 2021 it was a multiple choice question, nothing in 2020, does that mean that the only mention of spheres in 2024 will be a multiple choice question? No, it doesn't. Look, they might put like a 7 marker on there all about the equations of spheres. But I see a pattern here. Is the pattern going to hold? I don't know. But, you know, if you were limited in your time, if you're thinking, what am I going to study? What am I not going to study? Well, maybe spheres is something you want to spend a little less time on. No responsibility here if there's like a big question on spheres. I'm just showing you what has been in the past. Okay, spheres, that's what spheres is. Let's continue our journey through the exams. Okay, vectors in 3D and planes. So I'm sort of putting a lot of this together, and obviously it's a little bit difficult at times to categorize questions. Sometimes questions are in like 2 categories. So I'm just making up categories here, and I'll try to point out when a question could like maybe be in 2 categories or something. Okay, in 2023, you can see there's quite a bit going on. There's 3 multiple choice questions. This one's an interesting one. I find most students don't really know a lot about how to deal with putting a parametric equation into a calculator. So it's something worth thinking about. And you can see this like big 6-mark question where you've got to deal with vectors in 3 dimensions. I, J, and K components, a nice little picture here, and you've got to interpret this like part A to E. I find students can be intimidated by these part A to E questions, but the reason there is a part A to E is because the QCAA is actually trying to help you. It's not supposed to scare you because it's big and lots of words. It's actually supposed to be one of the easier questions. It's scaffolded to step you through it. What else do I see here? Vectors normal to the plane. This is something we see a little bit throughout. If we take a look here, you can see we have a vector normal to the plane in 2022. A kind of really interesting question here, and feel free to pause the video or just like write down whatever timestamp we're at right now and come back and have a look at this question and have a think about it, because it's an interesting one. And then this one here, again, we've got some vectors in three-dimensional space and we're dealing with them in some way. In this case, we're finding the equation of a plane. Also the equation of a line. So equations of planes and lines, 3 dimensions, no picture here. But in 2021, we go pretty big here. You can see sort of maybe overrepresented compared to the previous years. There's 12, 13, 14 marks here. We've got a three-dimensional like pyramid, finding an area of it. We've got planes and lines, things like that. And a couple of like vector normal to the plane. So every year we've got like a vector normal to the plane question. So, it's probably on there. It's supposed to be very basic, supposed to be very easy. But you'd be surprised how many students struggle with this one because there is a small trick to it. Now, if you do want to like learn the trick to it, a good idea is to just go to the search function of that Exam Insights website that I was talking about earlier and just start typing like a vector normal, and then this question will pop up. And then you'll be able to like click the video solution and just see what's going on with it, because it is a question that kind of throws people because it doesn't work out exactly how you think it might. Anyway, just something to think about. This one here is an interesting one, but again, scaffolded. The whole point of this is it's supposed to make your life easier. Okay, and 2020, they went absolutely bananas on this, I thought. So you can see there's 2 questions with like 3-dimensional diagrams here. There's like some vectors colliding here. There's an angle between 2 3-dimensional vectors. There's an area of a triangle created by 2 vectors. And then there's some other 3-dimensional stuff as well. 2020, notorious. I think they were finding their feet here. I wouldn't take this page as representative of something you might see, but what I would say is in 2023, we saw like a nice little picture here. We didn't see it in 2022. We saw it in 2021. We saw like a couple of those in 2020. If 3-dimensional stuff is something that you have trouble with, like this kind of idea, I wouldn't bank on it not appearing again in 2024. I think something like this is quite reasonable to assume that it'll be there. So definitely something you want to take a look at, figure out. I briefly mentioned a question here on vector collisions. We'll see vector collisions again when we start talking about some of the vector calculus stuff that they cover. Vector collisions, things colliding, seems to be something that pops up over and over and over again. So keep an eye out for it. Okay. Brings us to vector calculus. So let's talk about vector calculus. I sort of see this as being in a few different ideas. So looking here though, 2023, 12 marks, 2 difficult questions. Question 19, complex unfamiliar. Question 17, I consider that like complex familiar. In 2022, however, totally the opposite. 1 simple familiar and 1 like simple familiar, 1 multiple choice and 1 simple familiar. So like 7 marks and relatively straightforward, easy. 2021, we're back. We've got a really difficult question 19, a collision. We've got a question 14 and a question 3. Now, I've sort of looked at these vector calculus ones, and they usually be in 2 sort of modalities, right? We've usually got some kind of like projectile going on. So you see it in 2021. You see it again in 2023. So 2 projectile questions. If you go to 2020, the notoriously insane, ridiculous, this is the only vector calculus question that was on there, but it would have taken half an hour to complete the question because it's got so much going on. So don't use this as an idea, but projectile, skip, no projectile here, and projectile here, in here. So that's kind of the one modality of vector calculus I see. I would assume that we're going to see another projectile this year. It seems likely. The other question types that we're looking at are not projectiles. Vectors moving, yes, and maybe colliding. So we've got a collision here. Really interesting collision because they kind of take off at different times. So interesting question. This one here, we've got two particles colliding, but it's a question 11, a very straightforward scaffolded collision. And in 2021, I want to say collision, but it's not really a collision, but it's kind of is a collision. It's two objects moving, but instead of colliding, instead of finding out when they collide, you're finding out when they're a specific distance away from each other. Similar to a collision, same sorts of ideas. So that's kind of what I'd be gearing up for. Some vector calculus in the form of a projectile, some vector calculus in terms of like objects in motion, possibly colliding, possibly being some set distance away from each other, possibly being at right angles to each other. Not because I've seen it in a past exam, but because I've seen it in enough textbooks to think, hey, if we're doing vector calculus, if we've got two objects, maybe let's find the time when they're at right angles to each other. So something to keep an eye out for maybe in your textbook because you won't really find it in past papers. Okay, that's vector calculus. That's what I'm seeing there. Let's move on. Oh, let's get out of there. Okay, now I guess maybe bad news for Gaussian elimination lovers. Not a great deal of Gaussian elimination anywhere in these exams. So 2023, no real Gaussian elimination. I guess you could sort of say this is Gaussian elimination, but we'll come back to it. There's Gaussian elimination in 2022, and it's worth 7 marks. So they are asking you to do some Gaussian elimination. It's a slightly more difficult one because you're finding a value for lambda that gives the equation infinitely many solutions. So not a straightforward Gaussian elimination. 2021, no Gaussian elimination, but this thing here called matrix algebra. Now, this one here is quite an interesting question. It's sort of something you don't see a lot in textbook situations, not that I've seen anyway, but it is like a very specific kind of question. You'll find also, if you attempt this one and you think, oh, I never would have thought to do that, there is another question just like this in the QCAA sample paper. I'm not just like this, but using similar techniques. So something to keep an eye on. But I'm diverging. I'll come back to that. Gaussian elimination, like I guess you could call this Gaussian elimination. And then this is not Gaussian elimination. So the only time you really got to flex your Gaussian elimination muscles was in 2022. Get a big 7 marks there for being able to do some Gaussian elimination in a slightly difficult way. Am I imagining we'll see some Gaussian elimination in 2024? Like it feels like a hole. It hasn't really been there much. Maybe, but who knows? Something that I think students haven't particularly done well on in the past is matrix algebra. And so matrix algebra is more strongly represented than Gaussian elimination across the 4 years. You'd call this a matrix algebra question where you're solving a matrix algebra equation, getting 5 marks for it. You'd call this a matrix algebra question, but it's a calculator one, so you're just putting stuff into your calculator, like rearranging that equation and putting it in your calculator. You'd call this a matrix algebra one, and this is again where I would say, try that question. If you don't know how to do it, that's fine. Remember, it's going to be a tech active one. If you don't know how to do it, go to the sample paper, check out that sample question that also uses matrix algebra. Note, it does say specifically, use matrix algebra. Look for that cue in the exams because I think it's a high likelihood that it will be in there. And if you end up using Gaussian elimination, which you actually could use as part of this question, instead of using matrix algebra, you're going to run into trouble. If you don't know what the difference is between Gaussian elimination and matrix algebra, make sure you talk to your teacher about that to get a little bit of a guideline on what it means when you're cued by the QCAA to use matrix algebra, because it comes up in the sample and it comes up here in 2021. And then 2020, another piece of matrix algebra. So I think matrix algebra is being more strongly represented than Gaussian elimination, and that's probably where you want to make sure you take a look at it. Interestingly, if you're a student that follows the Cambridge textbooks, you won't find a great deal of matrix algebra in the Unit 3 and 4 textbook. You'll find it in the Unit 1 and 2 textbook. So take a step back, pull your Unit 1 and 2 textbook out, go and find some matrix algebra in there if you want to practice it. But also, practice these things. Okay, that's matrix algebra and Gaussian elimination. Next up, Leslie dominance matrices. 2023, what do we get? We get 2 multiple choice questions. That's it. So not a great deal here. In 2022, we get dominance matrices as a multiple choice question, but then we get Leslie matrices, we get 5 marks for it. In 2021, Leslie matrices, and we get 5 marks for it. And in 2020 was the only time we had a short response question that was dominance matrices. Now, what does this mean? I think it means you can expect to get about 6 marks for Leslie and dominance matrices combined. I think it would be too kind of the QCAA to give 1 short response for each. That's not going to happen, I don't think. It depends on what you think is going on here, but I think with no short response in 2023 for Leslie and dominance matrices, I feel like we'll see a return to Leslie and dominance matrices being a short response question in 2024. If you had to guess, what would you guess? Maybe you'd guess that we're going to see some kind of dominance matrices thing appear because it hasn't happened since 2020. Or I find dominance matrices questions really boring to write, not super exciting to write. So the Leslie matrices ones have a bit more meat on the bone. They seem a bit more interesting. So maybe that's why we're seeing over-representation of Leslie matrices. So I think there's not a lot of they're not difficult questions. They're kind of free marks. So be on the lookout. Keep an eye on them. Something you want to keep in mind is that I think there's a good likelihood that, like in 2022, you have to be able to take Leslie matrix data and take it from there to a matrix, right? They were very kind in 2021 with kind of setting up a matrix for you a little bit. But here as well, when they were doing dominance matrices, you had to be able to get information from one form into the matrix. And I think that that's going to be like the trick when it comes to either Leslie or dominance matrices, is making sure you can get it in there and then work with it. Also worth noting, because they're large matrices, 4x4s, 5x5, 5x5, you got to be able to use your calculator. Check it out. Make sure you can put a 5x5 matrix into your calculator and raise it to the power of 2, raise it to the power of 3 fairly quickly as well. You don't want to end up spending half your exam doing that. So keep that in mind. Easy, nice. Let us continue. Okay. Complex numbers. We're going to go through a few different kinds of complex number questions, but this is one that I feel like I need to draw your attention to. Question 18 every year has been this weird kind of complex number question that relies on your knowledge of the conjugate root theorem, the remainder theorem, the factor theorem. What else? Some of this has kind of a bit of De Moivre's theorem hiding in here in places. But these questions feel really predictable. Now, the same kind of question appears over and over and over again. All these questions have nice little twists and turns in them. No two are alike, but they are all using that knowledge of factor theorem, remainder theorem, conjugate root theorem. Often you're like equating coefficients to figure things out. De Moivre's theorem appears in here, like I said. So maybe my advice to you for this is if you're aiming to do really well in this exam, you want to get the 6 marks for these. These are all considered sort of complex, unfamiliar questions. What I would suggest doing is looking up this question on Exam Insights and attempting it. If you can't do it, watch the video of me doing it, right? And just like watch it at like 1.25 speed because it's on YouTube. You can watch it fast. And then straight away, try this next question. And then if you can't do it, and you probably won't be able to, straight away watch the video of me doing it, right? And then attempt this third one and then straight away watch the video of me doing it. And then attempt this one and then straight away watch the video of me doing it. Now, if you do all of that, you were probably talking about 45, 50, depends on how much progress you can actually make on these questions. Maybe we're talking about half an hour of video and maybe like half an hour of you working. So maybe it takes like an hour. But what you'll see is like a whole bunch of these techniques getting used over and over again, and like start to build your mathematical instincts for these kinds of questions. Now, the other thing I would suggest to you when it comes to these like complex number, unfamiliar style questions, just do a quick search for WACE Specialist Mathematics Past Papers. WACE is the Western Australian version of the QCAA, and the first result is the one you want. Now, when you do that, you'll see a whole bunch of past papers from WACE, from Western Australia. If you go to the 2023 Calculator Free exam, I can give you a good example. They're just so similar over there to what we are doing that you'll find questions that kind of feel like the ones that I'm talking about. So here, this is another version, probably a slightly easier version, but still something to test your knowledge of how these complex, unfamiliar style questions work. And you can find them in 2023, you can find them in 2022, you can find them in 2021. Go looking there because you can't find as many as you might want if you want to keep practicing them. Now, I don't know how many times I'll say it in this video, but obviously the past does not predict the future. So, could you spend hours studying these styles of questions and have one not appear in the QCAA exam? Sure, absolutely. I'm just showing you what the QCAA have done in the past. No predictions of the future. This is what we've got to deal with. Okay, moving right along. Subsets. I think students don't like subsets, which is good news, I think, because we're not seeing a lot of questions here. Multiple choice. So 1 mark out of your 120, so less than 1% of your marks in the last few years has come from this idea of subsets. Now, does that mean that they won't ask you a 5-mark question on subsets? Of course they could, right? I'm not going to keep repeating that, but this is the best knowledge we have. I also have this kind of instinct that the QCAA doesn't really enjoy questions that require students to sketch things. I just think those would be hard to mark for the external markers. So they're probably avoiding questions where it's like sketch the subset of this, which is probably the style of question that you've had more practice at rather than these styles of questions. So something you might want to sort of keep in mind, maybe have a look at some of these solutions, but if you're struggling for time, if you're not sure what to study, 1 mark each on these subset questions, maybe it's not worth a great deal of your time when you're allocating hours to each topic of study. Done. Okay, De Moivre's theorem. So if we look at 2023, again, there's little bits of overlap in these questions. So if I say a question is De Moivre's theorem, maybe it's technically De Moivre's theorem and something else. But 8 marks here in 2023, 12 marks. 11. Let's try again. 5 marks in 2022 and 7 marks in 2020. You might be thinking okay, but where's 2021? I think 2021 is kind of represented here, because they do use a little bit of De Moivre's theorem here. Also in 2023, this one also uses a little bit of De Moivre's theorem. So, there's a little bit of overlap here. Now, I will say, There were questions in the past where students didn't do particularly well. So for instance, I'm thinking of this one here. A lot of students didn't even realize that this was De Moivre's theorem. What you should note from all of these questions, if we go here, if we go here, if we go here, it's this concept of a circle, right? It's this concept of, all right, De Moivre's theorem tells us that the nth roots of a complex number are equally spaced around a circle. Equally spaced around a circle. Another way to think about that is it creates a regular polygon of n sides, right? I think the QCAA rightly likes students to understand that fact, that the solutions to the nth root of a complex number are equally spaced around a circle, form a nice little polygon, because it just keeps popping up over and over and over again. This picture that you're supposed to be able to either deal with in a really big way or just like a multiple choice question. So something you want to keep in mind, you want to think graphically in pictures about De Moivre's theorem, I think. Not a great deal to talk about here. This was just, like, if you want, pause the video and attempt this question. You'll get it wrong. Like, most students get this one wrong. I guess maybe because I've given you the hint that it's De Moivre's theorem, you'll do better than the average, but a lot of students got this one wrong when it should have been very easy if you understand that the nth roots of a complex number are equally spaced around a circle. That's my theory anyway. Okay. This is another one of those ones where, okay, they've done it so often now that it feels like a given, but who knows? In 2023, there's this lovely question. I think these questions are really nice, and once you've practiced them, once you've seen them, they're actually really easy to deal with. So you've got to prove that this is equal to this. In 2022, you had to prove that this was equal to this. In 2021, you had to prove that this left-hand side was equal to this right-hand side. So every time you're proving things, you're using direct proof. You're just proving that the left-hand side is equal to the right-hand side. Now, in this question and in this question, they tell you specifically, let Z1 equal A plus BI, let Z2 equal C plus DI. In this question, same. Let Z equal A plus BI, let W equal C plus DI. And that's literally all you do. You're just taking those values, subbing them in, and then operating on them until the left-hand side looks like the right-hand side. So not overly difficult questions, but I know that students get uncomfortable when there's no numbers anywhere to be seen. And here I can't see any numbers, so it like rightly freaks students out, I think. Question 13. Question 13 is an interesting one because you can do it multiple ways. They don't tell you let Z equal A plus BI, but that's how you should do it. You should let Z equal A plus BI. Now there is another way to solve this question where instead of letting Z equal A plus BI, you let Z equal A cis theta. And by putting Z into polar form instead of Cartesian form, this question actually becomes like really elegant and really beautiful as long as you understand how polar form operates, like what the conjugate of a polar form is and that kind of stuff. Encourage you to watch that video because I like it. It's a really nice proof. 2020, notoriously difficult. This question, like, I don't think it'll reappear again because I can only imagine how poorly students did in it. And they seem to have made the move to these much more simplistic proofs of complex number stuff. Could it reappear? Yeah, absolutely. And if you're the no stone unturned kind of person, you should definitely come and check this out. I said, where's the De Moivre's theorem stuff? You can see this one here uses De Moivre's theorem. So I guess in 2020, we actually had 7 marks, and then we had this 6-mark proof that used De Moivre's theorem as well. So really maybe overrepresented in 2020. But complex numbers as a proof, an idea, you're looking at 5 to 6 marks. Again, that's about 5% of your grade. So I think it's worth engaging with these, practicing these kinds of questions. They're nice. They are beautiful. Once you get the hang of them, like they're really, really nice. But I guess intimidating if you haven't played with them before. Okay, finally we come to kind of what I would say the simple stuff. If you look at 2023, 2022, two multiple choice questions, 2021, 2022 multiple choice questions, and these are really what I would consider just very simplistic, complex number style things. You can pause the video and take a look at these, but they range in like, some of them are like, this is kind of like, okay, how do you deal with polynomials over C? This one again is another polynomial over C, whereas this is just basic complex number, like just understanding how a complex number is written, I guess. This is the de Moivre's theorem. I've actually got that in the previous slide. Again, one that students did really badly at. Again, more like remainder theorem-y type stuff. This question and this question, I want to point this out. This is on a Tech Active exam. This is on a Tech Active exam. Your calculator can do more with complex numbers than you probably think. So you can type this directly into your calculator and get an answer. And you can type all of this directly into your calculator and get an answer. So if you don't know how to type complex numbers into your calculator in both Cartesian form and in polar form, get onto that. Ask your teacher how to like use your calculator in that particular way, because there will be a multiple choice question that, if you can do it, is free marks. If you can't do it, you'll end up spending like 3 or 4 minutes on a question that just should have been for free. So something to keep in mind. But every year, sort of 2 complex number questions in the multiple choices that I think are relatively straightforward, relatively kind of free. Okay, that brings us to the end of Unit 3. We're 36 minutes into this video, so you know it's going to be an hour-long video. If you need to take a nap, need to take a stretch your legs, go and get something to drink, we'll push forward into Unit 4. And exponential distributions is first cab off the rank. It's alternated, right? So exponential distributions, it gets its own category here in this slideshow. In 2020, it was like a 5 marker. This is, to me, this is method stuff, right? Like this is just a probability density function that's like got a specific kind of deal, but you actually could put that, like I can't see any reason that couldn't be on a methods paper, right? Because like even if a student doesn't know anything about exponential probability distribution functions, they can still deal with this. So that's relatively straightforward. If I look at this question, super intimidating complex unfamiliar question, but something you probably need to understand about complex unfamiliar questions from the QCAA's point of view is that there is a way to write them where you can kind of just give students information that they may or may not have, like, or may not have engaged with very much at the top of the question, and then use that as to move forward. So don't freak out when you see things like that. It's okay. You just sort of take it, go, okay, I've got that information. Obviously, they're giving me that information because it's important for the question. Let me interpret it and then start using it. Now, in 2023, 2022, we got a reprieve, not a great deal of exponential distribution stuff at all, 1 mark, right? So, if I was betting, I'd say it's going to make a comeback in 2024, but like it also just might not. So keep in mind, it's either going to be like a 5 marker or a 1 marker, not a great deal more than that. I'd also say that any methods study you're doing overlaps really heavily with this stuff. I'd say that a method student should essentially be able to solve these, having never seen them before. So moving right along, integration techniques. So obviously integration is like a big skill and you can use it for a lot of different stuff, but I've tried to sort of just create like smaller buckets. This is integration techniques. Really runs the gamut here. There's no rhyme or reason truly to anything from 2020 to 2023. You're not spotting a pattern here and like gaming the system, which I guess is a bit of a shame because integration is such a big topic, right? So if you take a look in 2022, we got some partial fractions going on in these multiple choice questions. This one is a U substitution, whereas this one is like straight up using your calculator. You could pause it and try to solve this, but you should just be able to type things into your calculator and have it spit out an answer. This is just from 2023, question 11, simple, familiar, very straightforward. I guess part B, some students find a bit tricky because it uses trig identities, but supposed to be straightforward. It's a question 11. Whereas we've got this question 19 question here, which is just a absolute like crazy business. Your integration by parts, like in a loop, like all sorts of weird things going on in question 19. So real gamut here, integration techniques. If we go to 2021, 2022, so again, like not a great deal of rhyme or reason to this. I guess if there was one thing that you might see here, it's that partial fractions made an appearance in a multiple choice in 2020, made an appearance here in 2021 as a 4-mark question, makes an appearance here in 2022 as a 6-mark question. So, maybe partial fractions is something that is like being overrepresented, but I think these are so all over the place that there's no real telling what they might throw at you. This question here, question 17, this was from 2020 again, really difficult stuff in 2020. Worth taking a look at it just to see the sorts of crazy stuff that's going on in a question like that. But integration techniques, linear substitution, U substitution, partial fractions, finding gradients of things, integration by parts, it's all at play here. And, it probably takes up about 8-9 marks. Just like by itself, maybe? Depends. Okay. I'm sorry about that because it doesn't feel like that's super helpful. But Simpson's rule. Okay, Simpson's rule is going to happen, I think. Feels like a bit of a given. Feels like it's going to be short response. Feels like it's going to be like 4, 5, 6 questions, 6 marks. Also, it's supposed to be simple, familiar, right? It's not supposed to be difficult. So 2021, we're finding Simpson's rule between this point and this point. We're told the function. Simpson's rule in 2022, we're finding the area here using Simpson's rule. A little bit difficult though because it's given as like an ellipse. So you're supposed to understand that you can kind of bend this like Simpson's rule to your will by just like rewriting it so that you only use the top half of it, like turn this into a function, y equals something, and then substitute values in. And then question 2023 uses Simpson's rule again, but no function at all, just like points. And what you should realize here is that you can draw a picture. And so much earlier in the video, I said, the QCAA is trying to be unpredictable here. So this is a good example of the QCAA using Simpson's rule in 3 different questions in 3 different ways. Here's Simpson's rule in a straight up function, shaded, find the area. Here's Simpson's rule in a relation, understand that you can sort of manipulate it and deal with it that way. Here's Simpson's rule, no functions, just points. And if you draw that picture and you understand what you're doing with Simpson's rule, you can find it that way. So Simpson's rule, I think, is 3 marks. It's like such an easy question, but it's worthwhile spending time because I think the question's going to appear, but it could appear in 3 different forms. Maybe QCAA has some other 4th way of doing it that I haven't thought about. So definitely worth checking out. Also notice that every time Simpson's rule comes up, the QCAA uses it as an opportunity to ask you to evaluate the reasonableness of your solution, evaluate the reasonableness of your answer. So that's definitely something that you want to keep in mind here. Don't fall into the trap of thinking that every time you evaluate the reasonableness of the solution, it will be reasonable. At least one of these questions, the answer ends up being not reasonable. So keep that one in mind. Simpson's rule, I think even though it's only worth 5 marks, it's worth investing some time in studying because I feel like it's going to be there. Areas and revolutions. So this kind of, I put these together because I think they're not used as often as I might expect them to be. Question 2023 is an area between two regions followed by a volume when you rotate that region around. Question 17 is the region between the x-axis and the curve when you're rotating that around the x-axis. So again, area between two curves. Area between the x-axis, volume between the x-axis and the curve. The trick with 2022 is that I believe that was tech free. So I think that's probably what elevates it to question 17. Whereas I think this was tech active. 2021, we've got an area and then an area between two graphs. In 2020, of course, the difficult exam, we've got this question here, which is volume of solid of revolution combined with a related rates question. Teachers love to combine two topics into one. It's a really fun idea. Actually doesn't happen as much in the external exam as I might expect it to. But something to keep in mind. So this was a two-parter. It's worth taking a look at because it's quite a fun one. I'm kind of surprised that volumes of solids of revolution haven't been used more in complex, unfamiliar sort of setups. I guess you could say that this is a complex, familiar setup. This is a complex, unfamiliar. But then in 2023, they kept things pretty low key. I guess you could say that this is complex familiar setup, but it's not because it's difficult conceptually. It's difficult because you've got to do some difficult integration. Okay, so I don't know how much I've helped you here, but it's probably worth 7 marks. Again, areas, volume's going to appear. Differential equations. Whew, wow. Okay. These take a lot of different forms. So, and I feel like I've said that for the last couple of slides, so I'm a little bit sorry about that, but I guess that's, I'm just the messenger here. I'm just showing you what I see. Now, we can sort of combine a couple of these things. So let's just let's draw some connections. In 2020, they had this really big, scary looking question as question 12, and it was worth 9 marks. Spoken before about these questions that are scaffolded. The idea is that it's supposed to make your life easier. Now, this question boils down to something called a logistic equation, and some of you are like, yeah, I've spent heaps of time in class on logistic equations. I know everything there is to know about logistic equations. But I have a feeling that the vast majority of specialist students probably haven't spent a great deal of time on logistic equations. Probably my own students included. Now, the reason I say that is because in 2023, this question appeared. And this is the worst a student cohort has ever done on a multiple choice question. Now, it is a little bit of esoteric knowledge about the logistic equation, and only 15% of students got the correct answer. But if you know stuff about logistic equations, this is supposed to be a 5-second question. You're supposed to look and just know. So what do I think? I'm in two minds about this, because on the one hand, I'm like, okay, I don't think students would have done particularly well on this. The next time the logistic equation was really dealt with in a specialist exam wasn't really until 2023. And when it was dealt with in 2023, students did really badly on it. So I'm in two minds. Does the QCAA go, okay, we gave them a multiple choice question in 2023. They did really badly on it. All of the specialist teachers should have spotted this and made changes to the way they teach. And so this year, we're going to give them another question that's closer to this. that really tests their knowledge of how to deal with logistic equations. And maybe not even scaffolded, maybe like a question 17, 18 that's really difficult, that's dealing with logistic equations. Or are the QCAA incredibly kind and they've said, okay, look, it's clear that the students don't know a great deal about logistic equations. We're not going to put that on the external exam. I don't know. It's something that I'll be very interested to see when I see the 2024 exam. Okay, what else have we got here? This is just a straight up like solving a differential equation. So understanding the idea, the concept of separation of variables. And so if you're not familiar with separation of variables, that's not going to make a lot of sense. If you are, fine. This question here is understanding, it looks strange because it's like, it's acceleration, but it's really more of a differential equation question. Like it could be a different context, not acceleration, some other thing, and you could still solve it. So usually when students are thinking acceleration, they're thinking about those acceleration formulas that are sitting on their formula sheet, whereas this is just like a differential equation, solve the differential equation. And then this question 18 from 2021, just really crazy question. Question that I hadn't really seen, like a question that looked like it before, but this is probably a good opportunity for me to say, hey, if you come across a complex, unfamiliar question and you just have no idea how to deal with it, like you just don't know, be aware that when every teacher, every student, every teacher comes to a complex, unfamiliar question, they don't know how to deal with it either, right? No one looks at a complex, unfamiliar question and knows how to complete it from beginning to end, right? And that, when I saw this question, certainly wasn't the case. But when you come to a complex, unfamiliar question and it says this differential equation, you can essentially stop reading. Like, and don't take me too literally when I say that, but when it says this differential equation and then I see a differential equation, I feel almost certain that my first step should be to try to solve the differential equation. Now, without even reading what the goal of the question is, I see differential equation, I solve differential equation. Is that going to get me the full 6 marks for this complex, unfamiliar question? Probably not. But if I solve the differential equation and then I keep moving forward, maybe I'll find out some more information and maybe I'll be able to move forward from that. So this is, again, because differential equations have so many applications, it's really a field day here. So you really just want to know how to solve differential equations and then trust that your skill in solving differential equations is good enough that you'll be able to apply it to any context. You might want to Google this. Like, when I say Google it, go to the glossary of the specialist syllabus. Go to the glossary of the specialist syllabus. Okay, moving right along. Implicit differentiation, real pattern here, right? And so the thing that you want to notice when it comes to implicit differentiation is the QCAA thinks that implicit differentiation has one purpose. And that purpose is to determine the equation of the tangent to the curve. So in 2023, there was some implicit differentiation, pretty hard one too. And then you were supposed to determine the equation of the tangent to the curve. Here, there's a multiple choice question. The gradient of the tangent at point A on this curve is 1.36. The x coordinate of A is, and here, determine the gradient of the tangent to the curve. So this is what I think implicit differentiation is in the QCAA's context. We've got some kind of relation and we're finding the equation of the tangent to the curve. That's my guess. It doesn't feel like it's been super represented, implicit differentiation. It really feels like it's been underrepresented. I'm not sure why that is. Maybe it feels like it's limited in its scope and use. I don't know. But 2023 was the first time we saw real marks allocated to this kind of thing. Next up, slope fields. Now, in 2020 and 2021, one multiple choice question. In 2022, first time marks were allocated, 4 marks for a slope fields question. 2023, no slope fields at all. Now, I am imagining, like, if I was, what is going to happen in 2024, I think you'll see the return of just a multiple choice question for a slope field. For the reasons mentioned, I don't think the QCAA really likes, asking people to draw sketches and things like that. And when you look at the southern states and the way that they deal with slope fields, it's generally dealt with in multiple choice questions. That said, there is a particular technique for solving slope field multiple choice questions that students who haven't been taught it before have no idea how to deal with it. So you might want to have a crack at 2020. If you have been taught the technique for solving that, it's very easy. It's super straightforward. You'll get it right 100% of the time. If you haven't been taught the technique for solving a multiple choice question that involves slope fields, impossible. It doesn't make any sense. So definitely check it out. And then you can Google New South Wales past papers, Victorian past papers, and search in there for slope field, multiple choice questions. They're always in there and they're always kind of the same. So you can get plenty of practice on them, but again, they're worth, it's 1 mark for a multiple choice question. At the very least, just go into Exam Insights, type the diagram shows a slope field, find that one, attempt it, get it wrong, watch the video of me doing it. It'll be a few minutes long, and then you'll know how to do it for life. Whoop, that was a crazy zoom in. All right, let's keep going. All right, related rates. Related rates, again, it doesn't feel like there's been a great deal of related rates. Although saying that, maybe I'm telling a bit of a lie. Because in 2021, we had this nice scaffolded related rates question where it stepped you through a bit of a classic of the related rates genre, like a cone filling up with water. In 2023, this related rates question, but not as classic, right? It's parametric equations, x equals 2 tan theta and y equals 3 sin 2 theta. And you're supposed to realize that you can treat it as a related rate because you've got an equation for y, an equation for x, and like an intermediary variable in that theta. So a kind of a different form of a related rates question. Now, I said I'm telling a bit of a lie because related rates also made an appearance here in this circular bowl question, because once you've done the volume of solid of revolution, you've got to then move on to doing some related rates. So I take it back. Related rates, the only year it really didn't make much of an appearance, 2022. Every other year it's been 5 marks, 8 marks, or in 2020's case, it's been, half of this question. You probably could have gotten 3 or 4 marks on this question probably 3 marks if you didn't know what related rates were, because you could have done the volumes of solid of revolution part. So related rates do pop up, but be aware that, again, the QCAA doesn't want to be predictable here. So they're not going to make the mistake of just doing related rates in shapes, right? Here was a case of them doing a related rate in a different way. So something to keep in mind. Those related rates can sort of be a little bit disguised. Keep an eye out for them. If you go through the whole paper and you can't find a related rates question, double check and see if you can figure out that one is a related rate, even if you can't find the word rate anywhere, because it might be hiding somewhere. Okay. Forces and momentum. Now, these questions take a couple of different forms. So one key component here is if you've got a couple of vectors going on here and you're determining the magnitude of the resultant force. Okay, so we're doing forces. Force equals mass times the acceleration. But in this case, there's no masses and acceleration. It's just all forces and you're just combining forces. Here, however, you're determining the magnitude of the momentum. Now, I think momentum is probably underrepresented in textbooks and stuff, but momentum does appear quite a bit in the QCAA's mind. You've got a momentum question here in 2023. Momentum is a multiple choice question in 2022. A don't know if momentum here in 2020. So momentum appears, I think, more than you probably see it in textbooks. Also, obviously, you need to know about force quite a bit. Again, I feel like Unit 4 definitely has like a lot of applications, so you end up with a lot of application-y type questions and like a breadth of applications. Now in 2020, we've got an inclined plane and some forces going on there with acceleration, so important to sort of note what's going on here. In 2022, there was another inclined plane, this time with a picture. In 2023, not an inclined plane, but two forces acting on an object. Quite often we're getting two forces acting on an object. And then this is just like determine the time of the particle has a momentum. So momentum. All over the sort of shop here, probably the thing I want you to note is you don't have the formula for force in your formula sheet. You certainly don't have the formula for momentum in your formula sheet, but you're going to need both of them to be able to engage with these kinds of questions. Tricky stuff. Now, probably also worth noting that these questions appear in higher difficulties. Question 17, question 16, question 17, that's where they make their appearances, apart from like the multiple choice single markers, which are they're always just putting stuff into a formula. Okay, I've called this topic acceleration, and by that I mean these are questions where you needed some knowledge of how to deal with acceleration in different forms. So acceleration as a function of displacement or acceleration as a function of velocity. That's the sort of thing we're looking at here. Now, this question here was acceleration in terms of displacement, and it was simple harmonic motion. This is velocity in terms of displacement, and it's supposed to be simple familiar because they're kind of scaffolding you through it. This one here is simple harmonic motion again, and this one here is acceleration in terms of velocity. So you've got to be familiar with those formulas where acceleration is in terms of something else. Probably the important thing here is to remember, don't forget that just because you see acceleration, don't put your methods brain in and just start deriving things. Usually in a specialist exam, acceleration is going to be in terms of displacement, or acceleration is going to be in terms of velocity. So you've got to get your formula sheet out and use one of your alternative formulas to deal with it. It makes an appearance. Weirdly, like you can see it kind of like heaps in 2020 and then like a little bit in 2023. So not like an enormous level of appearances, which seems strange to me. Seems strange. Okay. We are on the final topic, and the final topic to me gets overrepresented quite a bit. There's a lot of marks in the QCAA external exam in unit for whatever this topic is, whatever the stats topic is. Now, sort of broken it into a few sections though. So what we're going to call stats general knowledge. 2023, 2 multiple choice questions. 2022, 2 multiple choice questions. 2021, 3 multiple choice questions. And 2021 multiple choice question. All of these questions, I think, do not require calculation at all. They're tests of knowledge. They're more like the sorts of questions you appear on like a biology exam or something like that, where you're supposed to just know something and like know it, right? Not calculate it, which is strange to mathematics students. We do so little of that. So these questions are probably questions that you're not going to be super comfortable with, not super familiar with. Highly recommend checking out a video on this question or on this question. They're two very similar questions. You know, it wouldn't be crazy if they were to appear again. The technique for solving those is, because you're not doing true calculations, the technique is a bit weird. So you want to check that out. And this is just straight up knowledge. This is just straight up knowledge. Understanding what this picture means and represents is something that's very, very important. Which sample used the largest sample size? Here again, we get a similar kind of picture again. This is straight up knowledge. So understanding what this picture means, relatively easy question though, I think. And then this one is like the effects of increasing sample size and increasing confidence interval, or vice versa. And I think that that's something you're going to see when it comes to that knowledge. What does increasing the sample size do to your confidence interval? What does to the size of your confidence interval? What does decreasing the confidence level do to the size of your confidence interval? A good question to ponder, I think. Okay, confidence intervals. You can see 11 marks in 2023. Now, keep in mind, this question is kind of half sample means, half confidence intervals. But this one is really like straight up confidence intervals. Confidence intervals. Although this again is kind of half sample means, half confidence intervals. This is where the lines get a bit blurry. But you can see quite a few marks here. Confidence intervals, again, about 8 marks in 2021. Confidence intervals, about 8 marks in 2020. So I think that these probably get overrepresented a little bit. You can see also that quite often they have made up part of, let's go back to here, part of your complex unfamiliar questions, or at least your complex familiar questions. So a complex unfamiliar question here, a complex familiar question here, probably one of the easier ones they've ever done. Simple familiar there, but then a return to complex unfamiliar here. So will it be easy? Will it be difficult? I don't know, but will it be there? 100% it'll be there, and it'll be there in well represented. Like, you are going to see quite a bit of confidence intervals, or confidence intervals combined with sample means. What lesson should you take here? You've got to be good with your calculator, because these questions here, you want to be able to just jam them straight into your calculator and have it spit out an answer. However, when the questions become complex unfamiliar, when the questions become complex unfamiliar, where's 2023? Complex unfamiliar, not only do you have to be good with your calculator, but you also have to be good with the formula for confidence intervals and be willing to, in this case, know the confidence interval and then use the formula to rearrange to solve for something else. So, something to keep in mind, confidence intervals, they will be there. Be comfortable with them. Get on board with it. Love your calculator. We now come to the last topic, sample means. Now, keep in mind that it's not going to look as represented as it actually is. Because remember, when we were going through confidence intervals, I was saying, hey, some of these questions are sample means and confidence intervals. That's going to be the case here as well. So, for instance, we've got sample means here in 2023. This question is straight up sample means. This question is straight up sample means, but also in 2023, there was this complex unfamiliar that was half confidence intervals, half sample means kind of thing. I think. In 2022, we've got these 3 questions that are all sample means, but also like a little bit of like confidence interval-y type stuff. So you can see the overlap here, but it feels like for the amount of time that your teacher probably spent on this stuff, it does get overrepresented in the exam, which for some of us is going to be a good thing because I think they're relatively easy. But if you put your fingers in your ears and you weren't interested in this topic when you were learning it, Now is really the time to make sure that you get it on board with it, because I feel like it does get overrepresented a bit. In sample means, we've got 2021. It looks underrepresented, but I bet if we go back to confidence intervals for 2020, we'll probably see some questions. Determine the mean. Maybe not. Maybe a little underrepresented in 2021. Finally, in 2020, we have these sample means. We've got about 8 marks there. And then if you go back to confidence intervals, a little bit of sample mean stuff there as well. So I think quite overrepresented. The last topic, anything to do with statistics, because we've got sample mean stuff, because we've got confidence interval stuff, because we've got stats general knowledge stuff, if you're trying to find a place where you can get maximum reward for the same amount of study time, I would definitely be going to stats. Everything here, there's marks here to be had if you're looking to maximize your study time. Okay, that is everything. Now, did you get any smarter watching this video? Probably not. That's not what happened here today. What the goal of this video was for you to open your eyes to what the QCAA has put on their past exams, and for you to start thinking about what you should be studying, looking at those questions and going, you know what, I've no idea what any of that's about. I should go and check that out. Or starting to look at questions and going, okay, that's not worth my time. I feel like I know enough about that stuff at the moment that for the small amount of questions that the QCAA has put on there in the past, it may not be worth my effort. What you do need to do from here is start working. Start working towards understanding all of this stuff. Start jumping in and saying, okay, you know what? I remember he mentioned Simpson's rule. Simpson's rule is going to be on there. I like Simpson's rule. Let me just make sure, refresh my memory, make sure I'm on board with Simpson's rule. Now, that's a decision. Some of the others of you may make the decision that Simpson's rule, I know everything there is to know about Simpson's rule. I can tick that off my list. I'm not going to visit any of these questions. This one's probably a good one for me to have just randomly chosen because it is so, each question is unique, and the QCAA does love that idea of testing things in multiple ways. So even if you think you really know Simpson's rule well, you might want to take a minute to pause on this slide and really think about it. Speaking of which, I'll probably make this slide deck available somewhere. You can go and check it out. So this video has been 70 minutes long now. So you've probably forgotten half of the things I said throughout this video, which is fine. Probably a good idea at this stage is just to hit pause and just scroll through the video and just pause and think about particular question types and what you are actually studying at the moment and whether it's getting you closer to understanding the exam or further away from it. Apart from that, it's time for you to start studying. Good luck. This has been my Guessing the Specialist exam video for 2024. So if you're in the comments asking me when am I going to do it, this is the one. Go and check it out. You've got lots and lots of questions you can study. It's on you now. Good luck.